Hi, good afternoon, everyone, and welcome to this afternoon's webinar, which is titled Cloud Collaboration for Structural Engineers, which is in fact a joint effort from the SAICE IT division and the Structural division. My name is Peter Webb. I'm currently the chairperson for the IT division. And I'm just going to take 1 minute to explain to you a little bit about the SAICE IT division. Well, the focus of the IT division is to add value to educating our industry on new technologies. That's new developments, for example, Fourth Industrial Revolution, artificial intelligence, BIM, cloud collaboration, Internet of Things, that type of thing. Both from a hardware and a software point of view, and not forgetting the human perspective. And to how we can reimagine our workflows through 2022 and beyond. So in line with those objectives, the division seeks to, one, expose new technologies that may become useful to the civil engineering profession, particularly as the traditional boundaries between those engineering disciplines are becoming increasingly fluid. Secondly, we focus on serving our members by providing relevant content timelessly, always taking into account their needs. And thirdly, to attract more professionals into the industry, particularly by encouraging the younger and the older professionals to become aware of new technologies, whilst always maintaining regard to the social, environmental, and economic impact that these technologies may have. So a couple of things that Debbie wanted to mention in terms of housekeeping this afternoon. Please, if you have questions, please put them in the Q&A and not the chat. So if you put them in the chat, we won't be able to see them. But if you put them in the Q&A, then we'll be able to answer those questions after our speaker has finished the presentation. The second item Debbie wanted me to mention was that in terms of EXA accreditation, the CPD point system. Well, currently EXA is redoing their system. And so currently no accreditations are being issued. So just be patient and wait when those systems get sorted out, and then I expect the accreditation process will get back into gear again. So I'm now going to hand over to Payman Byron, who is the current chairperson of the Structural division. Over to you, Payman.
Thank you very much, Peter, and good evening, everybody. Thanks for joining us this afternoon, and I have the pleasure of introducing our speaker. Our speaker today is Mr. Harmony Mapundu. Mr. Mapundu holds a Master of Architecture from University of Johannesburg, and currently he is a project manager with Wordsview Technologies. Mr. Mapundu, in his role as a project manager, has in total 9 years of experience across commercial, retail, interior, mixed-use schools, and healthcare projects. He's a certified expert in BIM, design and project management. He has worked with a variety of capacities within leading architectural practices in South Africa. And currently he is seeking a dynamic career progression with an organization which offers exposure across the design and construction phases of his portfolio. With this brief introduction, I would like to invite Mr. Mapundu to take us through the presentation. Harmony is to you.
Thank you very much for that introduction, Payman. Good day, everyone. I'm sure we've all heard the term, no man as an island. This term is surely true for the construction industry because structural engineers work in an environment where they must both share information to and from multiple stakeholders on a project. So structural engineers on any project communicate with architects, contractors, they communicate with quantity surveyors. And today we are going to talk about how that coordination, that communication, and that collaboration can be done better using the power of the cloud. In my talk this afternoon, I'll be explaining why the construction industry needs this technology, considering where we find ourselves in the context of the construction industry. I'm also going to give you an overview of how we can utilize this cloud technology, collaboration using various BIM tools, and I'll also cover what we can achieve using the cloud, and I call these the 3 C's: collaboration, communication, and coordination. Next, I will then show you how some people have collaborated in the cloud and how it has worked out for them. And I've also created a few scenarios of how structural engineers can collaborate. So I'm going to be doing a live demonstration, and I'm going to show you what we can achieve as structural engineers using cloud collaboration. And at the end of the presentation, I'm going to open it up for a question and answer segment. So if you have any questions, as is mentioned by Peter, please post them there. Just a bit of background about myself, as it's been explained by Paiman. This is Harmony Mapundu, and this is a bit of detail about myself. I'm also on LinkedIn, where I regularly post and discuss about construction technology. So I'll be very, very happy to connect with you there. Let's start by discussing the environment which the construction industry finds itself today. As we talk to professionals in the construction industry, we start hearing over and over again about the challenges that we face day to day, day in, day out. Because the construction industry is now known for its traditionally low margins. According to Deloitte, globally, earnings before interest on tax on construction activities is just 5.5%. So even the smallest mistake we can make on a project, believe you me, it can make or break a project. We've also noticed that projects are becoming increasingly more complex than ever before. And at the same time, the schedules start to shrink. Did you know that McKinsey and Company found that 98% of the projects that we run in the construction industry today face delays? Then there's also the traditional problem that we all know in the construction industry of data silos. Data and information is extremely siloed, making much of the data that is produced during a construction project unusable. In fact, FMI found that over 95% of all the engineering data used in construction projects today, it goes unused. There's also another problem we face today of labor shortage, where AGC found that 80% of construction companies today cannot find the workers they need. And as well as COVID has brought us another challenge in the construction industry today, and the challenge is the challenge of distributed teams. Teams are becoming more and more distributed, with stakeholders split between various offices and in the field. And yet, a study that was done by FMI as well only found that 18% of the firms reported consistently that they were using mobile applications to access the project data, even though these teams are distributed. And then finally, the construction industry today faces uncertainty. Many of the challenges that we face bring uncertainty, and they bring risk into the industry. In fact, KPMG has found that 78% of engineering and construction companies do believe that project risks are increasing each and every day. But then, what are the other challenges that we face today in terms of the technology that we use? Because a lot of the structural engineering firms are using BIM technology. We found that clash detection is one of the bigger challenges that we face in terms of using this technology. And clash detection is usually handled by this one power user, who all the clashes and all the models being coordinated between the entire team are sent to this one person. And it also often causes bottlenecks in the entire coordination process. And a lot of attention starts being given to low value manual work. Information silos and disconnected workflows. When we work today, these are causing excessive time spent on manual processes. And therefore, you find that while we're working on these projects, we start missing perspective from the broader project team. And therefore, as a result, this reduces the overall quality of the project documents that we issue. The next slide is going to show you which is the biggest challenge we face today in the construction industry. And that challenge is the challenge of collaboration. As architecture, engineering, and construction projects are becoming extremely complex, we are starting to produce a huge amount of data. Historically, utilizing this data and syncing all this data and bringing all this data together was impossible. And it was one of the biggest challenges that we had in the construction industry, because the workflows we're using in the construction industry have been disjointed and disconnected. There's data silos across multiple companies, and these often lead to huge delays in communication, and a lot of time is wasted looking for the right information on a project. But for us as structural engineering firms, to deliver a project, there's a need of exchange of information within various stakeholders, which means from the general contractor, from the architecture firm, there needs to be a good exchange of information timeously. But the challenge is that the methods being used currently in the industry today are so disconnected that we end up losing the majority of the information that we produce. And that is very, very costly. It's so costly to the construction industry that 35% of our time in the construction industry, by being fragmented, is spent on non-optimal activities. Because it's been shown that 14 hours per person per week, that is actually 35% of our time being spent on non-optimal activities. $280 billion annually worldwide is spent on rework. And that rework has been caused by poor project data and project communication. This is from a study by FMI report. And lastly, it is amazing that 96% of all the data that we're producing while we're working on our construction projects goes unused. So this fragmentation of data has a direct impact on the project outcomes on all levels of the organization. Teams are working off outdated information because maybe we're using different apps. It leads to a lot of wasted time and a lot of security issues as well. The disconnection between the office and the field has caused massive rework. And as a result, it's causing an increase in project costs, the delivery time, and the profitability. And on a business level as well, having all this data that we're producing and having that data getting lost or going unused is reducing the potential of portfolio visibility. The construction industry now, it's urging for more connection from the people to the data, and technology plays a huge role in connecting these two. So for example, with the profit margin at stake, it's very, very important for us to catch issues before we go on to site. During the design process, we need to catch these issues and resolve these issues, because the model clashes that are caught on site can cost up to $3,500 per instance. And also, savings that come from proper clash detection can reach up to 10% of the contract value. And as I've mentioned in the previous slide, 280 billion in our industry is lost due to rework as well. So therefore, how do we overcome these challenges today? When surveyed, general contractors say that the highest value use case for BIM in construction is model coordination and clash detection. Many of the times you notice that a project goes on to site with so many clashes that have not been resolved. And when these clashes are detected on site, it results in a lot of rework, which in turn costs the client money. Now, if automatic clash detection was possible, that all the clashes on a project can be detected automatically, this could free up a lot of time that we spent working on clash detection, and we could deliver our projects quicker. Imagine if continuous collaboration could allow us to constantly address issues in real time, because we are collaborating continuously and not having to wait for that 2-week meeting where we meet around the table and we start coordinating, because that in itself makes sure that the project moves onto site at a much later stage. So imagine if we could collaborate continuously, that could save us a lot of time. And imagine if the construction industry could work off a common data environment, because if everyone is working on the common environment, it improves the design visibility, it ensures that the teams are working off a single source of truth. That is possible. And that, as a result, can cause our businesses to continue using the power of the cloud. Because with the power of the cloud, it's possible that the businesses can maintain business continuity, Everyone can start working from anywhere. We can gain insights on our projects. We can reduce risks and gain efficiencies in our day-to-day operations. And you know this well, because have you noticed that when the teams are disconnected, there's so many redundancies, there's so many areas that multiply. So if people are able to continue their businesses from anywhere, that could possibly change the way we work today. And also clarity. You need a clear way forward, because you need better visibility into insights of what you're doing. If your project teams are connected across the entire project life cycle, if the data is structured, it's easily accessible, it's easily handed over and exchanged, that could also improve the way we work today. And also in terms of visibility, if you could also see what all the project members on a team are busy doing, that could also reduce the risks. It could also give you analytics. You could predict where the project is going. And as managers, you also have better control of the project. And that is then possible by using the power of the cloud. Because by using the power of the cloud, teams can now work together in a connected way. Because we're now maximizing all the efficiencies that we have. We are all reducing all these inefficiencies, and we start avoiding rework. At the same time, these tools, by working in the cloud, they are flexible because we can work from anywhere. We can do the designs from anywhere. We can collaborate using these tools anywhere and anytime. And finally, using the power of the cloud is very, very powerful, because with the power of the cloud, you do not have to rely on your computing power, but all your project data is being stored in a secure place, in a centralized place, where you can also get the insights of that data. And that is the solution to all the problems that we face in the construction industry today, using the power of cloud collaboration. With cloud collaboration, this is where it all comes together to fix the problems that we face as an industry today. So what is BIM cloud collaboration? Well, the concept behind this cloud collaboration is creating a platform that connects the whole project team. So think of teams working together in real time, even though these teams are in different locations, and being able to collaborate together, even though you're using different softwares, even though we're working as different disciplines. You could be a mechanical engineer, a structural engineer, an architect. All of these stakeholders are using different tools. But can you imagine if they could all work together and have visibility of what each and everyone on the team is doing in real time? This can then make it easy for all the designers on the project to make edits in this one central cloud model that is sitting in the cloud in this common data environment. But also, the beauty about cloud collaboration is that even if you're not a designer, even if you're not a design author, you do not use any design authoring tool, but using the power of the cloud as an approver within a cloud platform, it will be great for reviewers. Why? Because you only have one place to review the project documentation. So let's say you're a manager or you're a project manager, you have all the information about the project in one place. You can provide inputs to the whole team in real time because everyone is connected on this one platform. And then there's also decision makers on a project. Through this cloud solution of collaborating using the power of the cloud, they can review the same model at the same time that the team is working on the same model. And they can do this through an internet browser. So if you have any device that is an internet browser, you are able to now participate in the design process. How are our clients viewing our designs? Do they wait for us to put them on PDF and then send it to them? But using the power of the cloud, even our clients can start reviewing our designs, can start participating in the design process, can also have visibility of our projects and watch the progress in real time. So cloud collaboration, in addition to what I've just mentioned, allows teams to understand the latest changes in a model. And all of this is in a combined view because it combines all the models from all the different consultants. All those models come together. You have one place to view the information, no matter what software it's been created in. And also, the power about cloud collaboration is that it has these project management tools that everyone can track whatever change or whatever information or whatever work has been done by anyone in the entire team, because they have these beautiful swim lanes in this cloud environment that allows you to be able to see what everyone is doing. And also, this is one of my favorite, using the power of the cloud, you can automate the clash detection process. So if one person has made something in 3D and it's clashing with another model, you can also see that this is clashing. Traditionally, we would look for those clashes manually, but using the power of the cloud, you can see that. You can also start to track issues. You assign issues to the people in real time, and then you can also manage change requests and then publish documents and send documents between the team without the need for using an email to be able to send a model to the other team member. But now you can publish that model to the cloud, and everyone in the entire team is notified of the model that's been uploaded to the cloud. So not all decision makers need to have an authoring tool, but they can also enjoy the power of using this cloud technology. So having a cloud platform is great for the entire team because it uses more than one design authoring tool. I've mentioned that most probably you're a design author and you're a structural engineer. And the amount of work that you're doing requires you to also coordinate with a civil engineer or an MEP engineer, because whatever they're designing is going to affect your design. You can use the power of the cloud to combine all of those models into one common data environment and to overlay all those models and to actually see that work in real time. Cloud collaboration can also work within the same company as well. Let's say, for example, this is a multidisciplinary engineering firm that's got a structural design and a civil engineering design department, but all of these can actually work together from the cloud, and as well as working together with teams that are outside your company. So these are people like your consultants that you also have on the project, and also external companies. You can all start working together with them using the power of the cloud. And you can also start managing all of these issues that are happening on the project. And because you're creating so much data on this, you can start having these project insights and you can start collaborating all of these models. But when we talk about the power of collaboration, people start thinking about the history of design collaboration, that we have been collaborating, but we have been using different tools. For example, who remembers a time when, if we're working in the same office as a structural engineering firm and we're working in one office and we're working on a model, and so many people, let's say, for example, 3 people have been assigned to work on that project. You would have what's called a localized central model that's sitting on the server in that particular office. And all of us would create a local model on our PCs that links onto that central model. So the problems with that way of working is that you had no visibility of who has done what, because that way of working had no internal activity tracking. So you'd not know who has done what. And also the collaboration there was limited because you could not collaborate with people outside of that office. And also the BIM management that would have to do with that central model and that central server was so great because there was a lot of management and work that we had to do to make sure that everything is being archived correctly. And then moved on to a time where people started setting up VPNs. So for example, this is a multiple firm that's working from different locations. People would set up VPNs and people could now connect to a central server that's set up somewhere. The problems with that was that it could only work for a single firm because you could not invite other external stakeholders to connect to your server because you would put your data at risk of being stolen. And also setting up that sort of technology was very expensive, as well as the problem that we had that the data exchange using these methods of collaboration was very, very slow. However, with the power of the cloud, if we can collaborate in the cloud, all the project stakeholders can take part in this project. So you're not risking your data. And then using the power of the cloud, multiple companies from multiple locations, they can also have managed access onto this and also working faster and in real time. And it also provides these extensive tools for project management and project delivery. So what are the benefits of working from the cloud as opposed from working off your local server within the company? Working off a local server, you can exchange data and you can also work share, but that's it. But then if you are working within the cloud, that means you can now invite people from multiple companies to work together. You have a visualization tool, which you do not have if you're working in a local server. And also the advantages of working on the cloud is that you can view all of this information on a device, whether it be your iPad or your phone or any tablet, but you can also take part in that design process. And lastly, all the data is going on to one place. So whether it be a quantity surveyor, an architect, anyone who's working on the project is sending that data to one place. So therefore, that saves us that problem that we mentioned at the beginning, that 96% of all our data is lost. But if we're all saving the data in one place, it would be a great value to our projects. What are the features that we face when we are collaborating on the cloud? So first, cloud collaboration platform should have a document management system or a document management environment, which should accept multiple files. So for example, this platform that we should have when we're collaborating in the cloud is able to accept 50 plus file formats. So whether you're working in PDF, it's got a PDF viewer, whether you're working in Excel, it has an Excel viewer, or whether you're working in any STL file, or any of those multiple files that we have in the industry today. This common data environment is able to host these files. Now, in this document environment, this common data environment, you're able to view the models, whether it be in 3D or in 2D, and you can start creating issues, you can start doing mockups, and I'm going to show you a visual example of how this document management system works when working in the cloud, when we do the live demo. And of course, one of the features and one of the biggest features of the cloud work sharing is that you are able to connect your design software. Whichever design software you're using as a structural engineer, you are able to connect it into this cloud environment, and you're able to collaborate even when you have the modest internet connectivity. Now, this cloud work sharing technology allows extended project team members, whether within your company or people that are outside your company, to work share, to be able to work together, to collaborate anywhere and anytime, because we are all storing this data on the cloud. So cloud work sharing is basically sharing whatever work I'm doing into the cloud and being able to see other people's work in real time, reducing the need or removing the need that we previously used to have of us having to email each other the work or the progress that we have done. The next feature of cloud collaboration is called design collaboration. Now, that's being able to set publishing, to set packages, to review, and while doing that, you have a high degree of control with whom your project data is being shared. Because in a lot of times when we're working on this project, we have got sensitive data, but you're able to send this data and limit the number of people that can see it as well. And having this unique ability to be able to do version control, to see the difference between each and every version of the design, because it's automated. The cloud understands your design, so it's able to detect what has changed from the previous version of your design. And the last feature of cloud collaboration is something that's known as model coordination. And then this allows all the models to be overlaid at once. So the architect model will be sitting on top of your model, and you have the mechanical engineer's model sitting on top of the structural model. And then the advantages of putting these models on top of each other is that it starts automating the clash process. So when one element is on top of another element, cloud technology or cloud computing power automatically picks this up, and it raises those issues as well. Now, a lot of structural engineers sometimes will double hat, or a lot of structural engineers sometimes become the lead consulting engineers on project. And they also take the roles of CPMs. Structural engineers can also take the roles of principal consultants, principal agent, and project managers sometimes. So if you're in any one of those roles, you'll be happy to know that using the power of the cloud, you can have real-time visibility of the project, because all of this project data now is being put in one place, and you can start creating dashboards and analytics of issues on a project, for example, quality, for example, risk, for example, safety, because you can start creating these automatic project reports, because the power of the cloud is that it understands what everyone else is doing on the project, and you can then create a dashboard that captures what everyone is doing. So you can know the progress of the project in real time without having to, rely on a consultant who comes and then gives you inflated numbers on a project. And this then allows project managers to make more informed decisions, because they can easily predict issues before they become costly holdups on a project. At this moment, let us talk about how the power of the cloud is capable of doing for a structural engineer. So what can the cloud do for a structural engineer? I talked about the 3 C's, and those 3 C's are better collaboration, better communication, and better coordination. Let's talk about collaboration then. If you as a structural engineer are concerned about alleviating the problems that we have having to collaborate with other team members and being able to co-author, with cloud collaboration, you have the power to extend work sharing to project teams in any location without any expensive efforts of distributed teams. So you're able to better allocate your resources and assign best team members with the most relevant skill sets for these projects as well. If your concern is security on projects, that the data that you're creating for your project needs to be secure, if you use the power of cloud technology, it gives you a great deal of flexibility to control who has accessed your design data. Because with this technology, you can start restricting users to certain folders or limiting access to certain companies or based on a certain role. So you can start controlling work sharing and design deliverable exchange with assurance that the right information is in the right hands throughout the entire project. If your concern as a structural engineer is efficient team coordination, you can then use the power of the cloud to ensure that your project team is always aware of the project's overall progress. Because with the cloud, you have these visual project management tools that you can start to track what each and everyone is doing. You can facilitate the model exchanges, and you can understand the changes between designs in the context of aggregated models in this one single space. And then with the power of the cloud, you have this powerful visualization that you're able to view your designs and be able to view the phase, you're able to differentiate which discipline it is, and you're able to know which building level, and you're able to do these cutouts and so much more in the cloud. Let's talk about communication. If your concern is accountability and ensuring that everyone else on the project is completing their tasks in a timely manner, with cloud, you can create issues and markups all within the cloud. Now, these features about creating issues enable you to pin these issues in context. You're now able to provide a comment thread, which is visible to everyone. You're able to add photos, you're able to assign work, you're able to set milestones and communicate whatever issues in a way that is very visible to everyone. With the entire project team involved in clash detection, you are able to resolve all the clash detection issues because using this visualization tool that I've mentioned, you're able to see whatever is clashing, you assign these issues to be resolved, and then that can be worked on. But you might want to see how it works, right? So let's talk a bit about how it works. So instead of emailing a drawing, for example, to an architect, how would a structural engineer collaborate with an architect in the cloud? Please allow me to show you the next demonstration.
Here, the architecture team creates a package and decides which content to include in this package. The package can then be explored and consumed by the other teams. Here, the structural team sees that a new package is available from the architecture team. After exploring the package and reviewing the changes that will impact their model, the structural team decides to consume the package. Before a construction project breaks ground, it is important to identify and resolve clash and constructability issues. Model Coordination performs automated clash detection of models hosted on the cloud, enabling design and trade partners to quickly identify and resolve model conflicts. In addition, users can easily create, assign, and track coordination issues to ensure accountability and resolution. Once the problem has been resolved in the Revit model, the team can create a structural package of their own and communicate their design changes back to the larger project team. The other team sees that a new package is now available on the project timeline. They can explore the package and use the Show Changes tool to better understand how the design has been changed. Once the changes have been reviewed, they can change the status of the issue and close it out.
Isn't that so beautiful? that we can start creating all these issues and resolve all these issues within one environment and not having to use this disconnected workflows. But how does a structural engineer collaborate with the rest of the team using the cloud?
Project teams communicate their design updates with each other using the Design Collaboration module in Autodesk BIM Collaborate Pro. Other teams get notified through the project timeline that a new package is now available. To make these changes available to other teams, the structural team creates a package, a combination of one or more sets to be shared. This package might include the Revit model, an IFC file, and other supporting documents. Once the structural team has created and shared this package, other teams will be notified via the project timeline in the Design Collaboration module. Here, the MEP team sees that a new package is available from the structural team. After exploring the package and reviewing the changes that will impact their model, the MEP team decides to consume the package. This updates the aggregated project model view in the Design Collaboration module, where you will see all consumed models plus your own work-in-progress model overlaid on top of each other.
The days of having project team members lie that they have not received an email with your model are over when you use this cloud technology. But as structural engineers, on Access Stage 3, we are required to coordinate these models. How can we do it using this technology?
In the Model Coordination module of Autodesk BIM Collaborate Pro, multidisciplinary teams can quickly identify and resolve clashes and design errors prior to construction. In Model Coordination, you can view models that have been uploaded to the cloud. From here, you can select models from your coordination space to use in Model Coordination. You can create saved views of a select group of models, which is helpful when working with subsets of a given project. Models uploaded to the folder are coordinated and instantly class-checked. You can view the number of active clashes between any two models in this matrix. Clicking on a cell will navigate to the clash location, showing you what is interfering between structural and MEP. This means you can easily review clashes without waiting for coordination meetings and precisely locate those clashes within your models. You can mark a clash as not an issue if it does not require further attention. Model coordination allows you to create and edit issues directly from clashes between models. The issue title contains the ID number to help track the element in the Revit model. You can edit issue details, add information such as location and due date, and then close the details panel. The issue owner will receive an email notification with a link to the issue. If you go to Build Issues, you can see the list of issues which have been created for this project. You can view issue details here. A screenshot of the clash also appears here. This was automatically captured at the moment the issue was created. You can easily change the issue status from open to in review, or even to closed once the problem has been resolved.
Let us now finish off by talking about where this technology is being used. You'd be happy to know that this technology of working on a construction project and collaborating using the cloud is being used in 150 countries. This technology is being used on 70,000 active projects right now, and there are over 150,000 models in the cloud, and there is over 10 million syncs. So this is how much people are working in the cloud. But here in our country, in South Africa, we have had many successes of people that have been using the power of the cloud technology. Let us look at one of them, which is an architectural company called SAICE based in Cape Town. And despite network connection and problems, they said that their design models remained intact without any of the data corruption because of using the power of cloud technology. So as architecture and engineering firms around the world are dealing with the COVID pandemic, or these teams are getting dispersed, other people have started exploring the power of the cloud, and it has really made the way they work better, because now they work better and they're achieving their deadlines in such a short time. Let us listen to a bit of an interview from some of the people that have used this technology.
Well, now that we've started working from home, we've adopted the BIM 360 method, which has essentially eliminated all the issues that we had when trying to connect to the server over long distances and trying to communicate across the team. The BIM 360 platform has also allowed us to, it's almost like a single platform where we can store all our information, and we don't necessarily have to worry or consider the back and forth between the connections and the different server files and folders.
One of the key tools of Revit we use is design options, where we switch between different options and see what will work given the typical scenario. And because of the fact that we are design-driven practice, the modeling process is an important way to assess that. We had an estate, a multi-residential estate in Mallorca that consisted of 7 apartments, and each apartment had 6 units and 2 penthouses. And 2 of those units were duplicated. With Revit, it allowed us to use the tool linking and grouping. So where we could make one change, duplicated across the units that were used more than once. And where a project like this, say on AutoCAD, for example, would take months, we ended up taking weeks. When we assess an AR, working with an AR, one of the key criteria is whether they work on Revit or the BIM 360 platform. And in doing so, we're able to live work with one another on cloud-based models. There are less room for misinterpretations, and our design concept is maintained throughout the project, and throughout the project timeline for that matter. And whether it be we are assessing the ducts from the mechanical engineer, conduits from the electrical engineer, and whether they work with the ceiling depths we propose, we are able to eliminate any room for misinterpretation, and without having to drag different drawings from across different folders, across different servers, and at the risk of using superseded drawings for that matter. So we are always doing clash detections and looking for areas, and when we do make a change, our consultants are able to assess them in real time as well. And in that way, we are able to maintain our design concept throughout the project. It is imperative to us that our documents are as engaging as possible to our clients, and with the 3D illustrations that we deduce from Revit, we are able to.
Well, now.
All right. And lastly, this is another example. This is an international example of Red Sea development. If you know anything about the Red Sea development, you'd know that is the 3rd largest giga project, and it's currently being delivered as part of Saudi Arabia's Vision 2030. And to deliver this vision, the client invested in the best-in-class technology and used the power of cloud technology to be able to make the decisions. And they actually have said that the cloud technology offered them speed, offered them a saving of 1,200 man-hours, because a lot of the processes that used to be done manually have been automated. So that is what we get using the power of the cloud technology. At this moment in time, I would like to finish off this talk by doing a live demo, just to show you what can be achieved, and just take you through different scenarios of how a structural engineer would like to collaborate with other stakeholders on a project. And you'd notice that there are several cloud platforms that are available on the market. There are multiple cloud platforms from vendors, and these developers are making this cloud technology happen to everyone, because the future is in the cloud. I happen to be very well acquainted with the Autodesk Cloud Platform. Therefore, I'm going to stop sharing my screen, and I'm going to open up a cloud platform, and I'm going to show how the collaboration could work in such an environment. Okay. I will be sharing my screen. So I've mentioned that this is a cloud environment. This cloud environment sits in the cloud. So it sits on any browser. So you can open up any browser and you can start exploring this technology on any browser. So for example, this is a platform where all the architects, the civil engineers, the drainage consultants, the landscape architects, the MEP, the team that is busy working on the roadway, the right-of-way survey, and the structural engineer, all of them are sharing this information into this cloud working environment. But maybe your question could be, how will this information then move from my design software to this cloud environment? You'd also be happy to know that there's so many firms or so many companies that have made their softwares compatible in such a way that they're able to share their information into the cloud. So for example, using the software, which is Revit structure, a structural engineer would have completed their designs. So they'll be working on their designs and have completed the structural design. There is an option to then share this design in the cloud. So what a structural engineer in such a situation would go to the collaborate tool and then click on share in the cloud. So the moment they do that, their model is able to be hosted in this cloud environment. So for example, a structural engineer would go on, let me just pick this level, on the collaborate tool and then synchronize with Central. So by doing that automatically, you are then sending your model to the cloud. So in this case, this model, I have already shared it with the cloud. But if you're working, for example, on a model like this one, which has not been shared to the cloud, what a structural engineer would do is click on collaborate, and then the model automatically is shared into the cloud. So whichever software you use, there is a cloud sharing functionality where you're able to then share this model into the cloud, and this model is then processed in the cloud. So it's then saved as a cloud model. I'm not going to spend much time on this, but you already see the advantages that now it lists all the projects that you have, the advantages that you can easily synchronize your model into the cloud. The beauties about some of this is that now there's even add-ins where those issues that have been raised in the cloud, they automatically come to your design software. So there's also issues tab where if someone raises an issue from their phone and they assign the issue to me, that issue comes straight into my design software and I'm able to respond to that issue. So fine, we have shared as a structural engineer, we have finished our designs or we are design in progress, we have sent our model to the cloud. That model comes into that common data environment that I've mentioned. And you will pick a folder where you have permissions to share that. So when you do share your model, depending on the permissions that are set on the project, your model then goes and sits on this particular place. And it also tells you the day which the model has been sent into that space. And it also shows you a version of that model as well. So what you can then do is you can view that model in this 3D space. You can also decide to share that model with the rest of the team if they want to then approve it. And then once you've gone, this model has been shared on this common data environment, you can view that model in this design collaboration view. Because, for example, you'd like to work on that model in the 3D environment. You are able, as a structural engineer, in a structural engineering place, click on project model, and you are able to view your project model. And you're able to see how your project model is interacting with the rest of the other disciplines. So, for example, in this case, our project model as structural engineers is interacting with the MEP model. And you are able to switch off the MEP model, and you're able to see how your model interacts with the rest of the other models. We talked about having these project management tools that are formed by swim lanes. I'm sure a lot of people might have asked, what is a swim lane? With the cloud collaboration platform, it provides all the project team members with visibility on what has been done by the other project team member. You can see that the architect consumed a model on this day. You can see that they shared this model on that day. You can see everything they are doing on this environment. So let's say, for example, the MEP team on this day shared a model. You're able to click on their model as a structural engineer, and you're able to click on the model that the MEP team shared, and then you're able to view that model, and you're also able to compare the changes that have happened from the last time the MEP shared a model, which was 15 Feb 2022, and this new shared model, because the power of the cloud technology automatically calculates using cloud computing power the number of changes that are happening between the old model. You know, in the old days, when you get a drawing from another project team member, you'd rely on these revision clouds. You'd ask for a project team member to show you what they've changed and how that's going to affect your design. But with the power of the cloud computing power allows you to deal with and to be able to view these models in that environment. As well as, let's say, for example, I'm going to click on back to home. Let's say, for example, you have received a model from an architect. You're able to click on that model, bring that model into the space, and you're able to explore that model and create issues and assign issues about that model as well. One of the things that I like about cloud technology is creating a watch group. And I'm sure every structural engineer here is aware of the number of times people can revise a design during a project. Because when a person makes a design, then you find 2 weeks later, they've revised it again. Now I have to revise the spacing of my columns. We can create what's called a watch group. And when we create a watch group, we're saying we want to monitor certain elements of this design from this particular team member. Let's say, for example, this architect is constantly getting inspired. So what you can do is you can click on architecture, and you can then load the architectural model, and you can then say this model from the architect. Then you click on next, and you then say, please, can I watch these elements? So from all the elements that this architect is going to make, I want to be notified on any changes to the columns. I want to be notified of any changes to the floor. When you do that and you click on next, and you then create a watch group, and then you say architect changes, and you save that. Anytime that architect makes any change to his model on those particular elements, that watch group is saved. It sends an email to you, and it also notifies you in real time when that change has been made as well. And also, with the cloud technology, we can start creating meetings from within this space. You can start creating meetings, and you can also start creating reports within this one coordinated environment. So in the meetings, this also links up to our meeting tools that we use to create our meetings. For example, if we have our meetings in our Microsoft Teams, we can add the links to that, and you can also add the meeting attachments, and you can also start having the meeting notes. All of this jotted down in this one environment. So it reduces the need to go into Microsoft Word and type out the minutes there, and also the distribution of the minutes and following up of action points. All of that can be done in this one environment. And also in terms of reports, the project manager has visibility of everything that is happening on the project at that time, because you're able to create these project reports. So that's just in basic, some of the things that a structural engineer can achieve using design collaboration module of cloud technology. Now, let us talk about another powerful feature, which is collaboration. So within collaboration, a structural engineer can look at their structural engineering design and then start to understand how their structural engineering design is clashing with the designs of another team member. So for example, you have this matrix that shows you that this is the structural model and this is the electrical model, which is showing electrical power. And automatically it shows you that you have 47 clashes between the two of you. So when you click on those clashes, it then loads each and every location where that clash is located. So it reduces work from structural engineers to try to have to look for each and every instance where their model is clashing with another team member's model. So we can already see in this case that this concrete floor is clashing with that element. And if we need to create some openings in that, we can then click on that issue that we have at that moment in time, then create an issue. And when we create this issue, we can then point at the place where the issue is, and then we can then assign that issue to a person who's responsible for resolving that. So for example, you might think as a structural engineer that the electrical engineer needs to move their lighting fixture or needs to move their fixture away from my beam. You can then create that issue. You can then assign it to the particular person you would like to assign it to. And on top of that, you can then select people who you like to watch whatever's happening on that design. So for example, you are saying that while this is happening, I want this person to have visibility on what's happening. You can set the due date on when this needs to be resolved, and you can also specify the root cause. Automatically, when it sends this information to that particular person and their email, they have a screenshot and they know when they need to respond to that. So that is the power of cloud collaboration using the clash detection tool. And this clash detection can happen between any discipline. If you as a structural engineer want to understand how your design is interacting with the other person's design, as long as they're working in 3D, as long as they've published their model, you can be able to see them. But for example, we've seen that there's so many clashes there, and there's so many clashes that could be negligible. Like, let's say, for example, you can set up a rule that a clash that is within 10 millimeter of tolerance is not a clash. It's a normal joint. With the power of this cloud technology, you can set your clash tolerances, and automatically the software knows that this is not a clash, and it ignores that. And one thing I really like about this is that it's constantly looking for clashes. So if someone uploads a model now, it is automatically looking for a clash, and it tells you that the last clash check happened at X number of time. So you can set it to say, constantly look for clashes. And from a project management perspective, I would know that these guys are the ones that are having a problem. So I can automatically see that there's 4,008 clashes between the architecture team and the structural team. Then I know that our efforts on this project need to be focused on these two disciplines, because there's a lot of elements that are not working well, and that needs to be resolved before we go onto site. And also, you can set up views to say, when I want to view this, I'd like to view it in this particular view so that I'm able to monitor this project. So you're able to do that with this cloud, as well as setting up meetings as well and setting up reports. But then how does a structural engineer who's got a structural design send their design to the rest of the team members? Well, it's easy. As a structural engineer, they can check their project model, and they can see that their project model is this is the issues we have, this is what we've done so far, we are happy with what we've done on this project. And then at that point in time, they can then go on this project management timeline, and I'm in this as a structural engineer, and then I say, I am now ready to share this model of mine with the rest of the team. You then create what's called a new package. Instead of emailing this model to the rest of the team, I can create what's called a new package. And then it shows me the model of the structural engineering model I've been working on. And then I can set to say, this is the information I'd like to send to the rest of the team. I would like the team to see a 3D copy, and I would like these documents to go with the team, and I save. This is a package that I'm now sending to the rest of the team. Once I save that package, I can share the package. And it asks me what the name of the package and what's the description of the package. And I could say weekly issue 009 or 009, yes. And then I can then share this to the rest of the team. Automatically, when I share this, the rest of the team is notified in their cloud environment that this person has shared a model, and the structural engineers have shared a model, and that model is ready for consumption by their team. So for example, I'm the MEP engineer now. I've gotten a notification that the structural engineer has shared a model. As the MEP engineering team, I can then go and click on the model that is being shared by the structural engineers. I'll click on the compare button, because by comparing, I would like to see that from the last time they showed me that they shared something with us, what has changed between those two situations. And I can see a visual and 3D representative of all the changes that have happened from the last time the structural engineers issued and this time. So in this case, the structural engineer did not change anything. It then shows you that they added nothing, they modified nothing, and they deleted nothing. And therefore, the MEP engineers could be saying, now we are happy to consume the model. So then they are able to do that and consume the model as well. So the same could happen to the structural engineer. When the structural engineer gets a notification that something has been updated, they are able to also consume that model and bring it into their space. Lastly, I would like to talk about this common data environment called docs, because in this common data environment, even if we're working in 2D AutoCAD drawings, we can still leverage on the power of the cloud. So let's say you are a structural engineer and you would like to compare two versions of these PDF drawings. You are able to do that because you are able to show that drawing and do a version control. Power of the cloud technology is that it can know what has happened in that PDF. So for example, I can put two PDFs in comparison, and I've put this first PDF as struct A, and I put the second PDF, and I ask this to say, this person who has issued us this PDF did not tell us the changes between the two designs, but you can actually use that to compare. And automatically it tells you that the grid line has been moved. So you did not have to physically look for the movement of the grid line, but you're able to see that the grid line has moved and you're able to do something about it. And you're able to create an issue, raise the issue with the person who has moved that grid line, and all of that can be done. So not only in 3D, but you can also do so much work in the 2D environment. How have we as structural engineers been approving drawings within our companies? With the power of the cloud, we are able to send drawings not by emailing a drawing, but to be able to create what's called a transmittal. Because with the transmittal, you're able to say a person who's supposed to accept your drawing, review your drawing, and then you're able to send the drawing to the particular person, and that person is able to review your drawing. You're able to add a message, and once they review that drawing is automatically sent to the rest of the team. And what's the beauty about that is that now these transmittal slips that we used to create in Microsoft Word, there's no need for us to create a transmittal slip in Microsoft Word anymore, because the cloud has noticed what we've issued to the rest of the team, and it automatically creates a transmittal and proof of what has been sent to this particular person, how many items have been sent, and how many times. So you're able to deal with those issues in this environment. You are able to review the project documents, and you're able to assign issues, all of this using the power of the cloud. So this is just a snippet of how our work as structural engineers, as construction professionals, and the need for us to coordinate with everyone on the construction project can be better when we leverage the power of the cloud. I'm going to stop sharing my screen, and I'm going to move on to the last portion, which is the feedback session. At this moment, I would like to invite anyone who has any questions about how this technology works and other applications of the cloud technology that we've just covered in an abbreviated format today.
Okay, thank you, Harmony. That was a very interesting talk. While our participants are compiling their questions in the Q&A, I've got a couple of comments there that sort of became apparent to me during your presentation. Then we were talking earlier, I mentioned about traditional boundaries between engineering disciplines are becoming increasingly fluid. I thought it was quite interesting here to actually see, that you've got many disciplines are actually able to collaborate on the same project. Also struck me that the idea of BIM was basically to decrease costs, as formed by government saying they had to reduce their costs, otherwise they couldn't afford the future infrastructure. And of course, one of those big things that was identified during BIM in the early days was that clashes on site between the different disciplines was something that was becoming quite an issue. And if you could solve those before it went to site, that would be a big cost saving. So that was also came across quite well. And also the collaboration of, not only working in the same office, but teams could, work across different countries now on big projects.
Yes.
Even if it's a small project, it seemed that, cloud collaboration was something to, that one could actually to use. So Debbie, have we got any Q&A questions in yet?
Peter, I'm just having a look here.
I don't see any at the moment.
Had some very good comments on how informative and inspiring Harmony's presentation was. Yes, we have recorded this session, and once it's been edited with Harmony's permission, we will place it on our YouTube channel and send the link to the delegates. We don't have any other questions at this stage, Peter.
Okay, I'm just seeing a couple coming in. One from Akshay. I hope I pronounced that name correctly. The question is, how steep is the learning curve for a beginner on cloud collaboration? How long would it take to become comfortable on this platform? And do you have any platforms for training that you can recommend? So I think sort of asking, how do you actually get to know more about this, cloud collaboration? So Harmony, if you'd like to answer that.
Okay, let me start with how can they learn on that. As I've mentioned earlier, there's different vendors and different developers that are creating these cloud platforms, and they're very eager on providing this education. And a lot of their YouTube pages have shown, they upload these videos on their YouTube pages, and they teach on how to use this technology. So in terms of learning, you would find that all the information that is out there is very easy to understand, and there's so many videos that you can watch on these YouTube platforms, and there's so many tutorials that you can watch from them that can easily equip you. And it's a web-based environment. So as long as you can navigate yourself through a website, that means you can navigate yourself through this web page, and it's a tool, and you can be able to work through there. And a lot of these vendors also provide support on this product. Once you have purchased it, they also guide you along the way in case you face any problems. So the learning curve is very, very easy. As you would actually realize that learning the software itself, the design and authoring software, might be more difficult than learning the cloud collaboration platforms.
Okay, thank you, Harmony. Next in the Q&A from Wesley. He says it's not really a question but a comment, and he says we've been using software like this since 2015 when it still used to be BIM 360. We have found that partners in the industry are not coming to the party, mostly due to costs. So have you got a comment on that, Harmony?
Well, that's a very interesting one. That the costs of the software are not as steep based on it being a cloud-based environment, and the costs are slowly becoming affordable. That depending on the user who you are, so a reviewer does not need an expensive tool because they do not need a collaboration tool, but an author would need a much more advanced tool. So there is a price difference, and that price difference is starting to cater for all the different people that use the software. But if a lot of these softwares, if you actually start looking at the time that you save using this collaboration, you would find that if you are spending 11 minutes a week waiting for a collaboration for your software to sync without using collaboration, that means you can actually afford to buy the tool, because these cloud tools would have bought itself. So the saving that you actually make by buying that that tool actually buys itself from the time you save while working on that. So it is estimated that if it's 11 minutes a week that you waste on that, then you're able to buy the software, and it will make great savings for you.
Okay, thank you, Harmony. I've got another question here from Elijah. He says, can this, I guess, be considered to link with the client, i.e. in a project you have the client or the ownership of the project? He says, especially with regard to payments for work completed. Otherwise, I guess he's looking for, you know, payment certificates being linked into the cloud collaboration software, I guess. If I'm wrong, Elijah, maybe you can just add some into the Q&A.
Okay, maybe in terms of that collaboration, as a structural engineer, you can provide visibility to your client, because clients traditionally would wait for that report that would give them every 2 weeks or every month. But with the power of this technology is that we've opened up and we're being transparent about what we're doing. And we've got a track record of what I did yesterday, what I did today, what I did, what I did the past month. So all of that information is captured within this cloud, and we can use that as a basis maybe to capture the number of hours we've spent doing a certain task, and we can use that to claim. However, I'm not sure when it comes to be able to use it for payment certificates. I will research into that, and I will come back to you if you could maybe email us with that question in more detail.
Okay, thank you, Harmony. Next question up is from Yasmin. Are there any platforms that offer demo models for people to learn before purchasing?
Yes, a lot of the vendors that offer this technology in the market actually offer you 30 days of trial. And within those 30 days, you can do everything, pretty much everything. It's not even restricted. You can actually participate in a project using the 30-day trial. So we've used different vendors and different modules of collaboration, and you can try it out using their 30-day trial period and see how you ease into it.
Okay, thank you, Harmony. Next question is from Terence. Are universities or higher education institutions being influenced to offer BIM as part of their curriculums to future engineers?
Yes, that is taking place. However, the pace might be slowly, but we are happy to note that during our research, we found that majority of the universities are starting to offer BIM technology, and also BIM standards are being adopted in South Africa, the 19650. So once that has been adopted, because we know that it's in the final stages of being adopted, that would also drive institutions of tertiary education. But we do know that the uptake has started increasing in the past few years.
Okay, thank you. And the next question is from Rwandili. Says, thank you for the presentation. How does the platform affect different software versions, e.g. Revit? Okay,
so the platform is irrespective of a version. So Wandile mentions a particular software called Revit. So if a person could be working in Revit 2016 as a structural engineer, and then the wet services engineer is working in Revit 2019, we can still collaborate together irrespective of the Revit version.
Okay, thank you, Harmony. We don't have any more at the moment. So I'm just looking through, make sure I haven't missed any. Looks fine. We'll just maybe give it a minute or so to see if there's any additional questions coming in. While we're waiting, I just thought of, you mentioned there earlier about, well, in fact, I think it was in one of the videos you showed, was about a comment about internet speed. You know, how would that affect? Are you able to only use the technology in where you've got really good connection, or is the technology able to be used when you've got, you know, slightly slower connections? Have you got anything on that, or anything to do with caching or something like that? Can you add a comment to that?
Yes. So the beauty about the cloud technology is that, first of all, when you do save something onto the cloud, it creates a local copy on your PC. So you also have a local copy that you're working on, that you do not need to have an internet connection all the time while you're working on this. But in situations where you now need to send your model to the cloud, this cloud technology is so intelligent because it already knows what it has. So if you sent your revision last week and then you're trying to send something that is new, this cloud has already cached what you already sent it. So it only updates what you have changed. And you realize that on a design project, whatever you have changed is in less than 10 megabytes. So you do not even need a very, very good internet connection. Even with a modest internet connection, you can actually sync all your changes into the cloud. It is actually faster because maybe this goes into maybe an entirely detailed IT conversation. But because of the way cloud technology works, it is actually faster to save onto the cloud than to save onto a server that's within your office. So that means the amount of data that's actually required to save onto the cloud is very, very low.
Okay, thanks for handling that question, Harmony. I don't see any more. So at the moment, just check the list. I can't see any more here. There's one, I think there might be something in the chat. Debbie, can you see anything in the chat there apart from the Q&A?
Yes, Nkosi has said, thanks very much for the presentation. Please help address on the file sizes when loading and minimum storage capacity.
Oh, that's a beautiful question. And that's one of the pluses I love about a lot of the vendors that have provided this technology, is that it's unlimited size. So even if you're working on so many projects and multiple number of projects, and the file sizes are maximum, even if your Revit file or your design file is of any size, there is no limit or maximum capacity of the information that this cloud platform can host. So you can upload as big of a file as you want, and as many projects with those multiple files as big as they are able to be hosted on this cloud platform.
Okay, so what you're saying, Harmony, is that there's actually no limitation to the storage space for all your projects?
Yes, there's no limitation
to
the storage space of your project.
Yeah. All right. I don't see any more. I'm just checking the last Q&A panel here. I think that's all the questions we've got. Debbie, shall we wrap up the session for today?
Yes, I think so, Peter.
Right. Well, thank you. Well, thank you very much to Harmony for giving such an in-depth presentation on cloud collaboration and how structural engineers can benefit from it. Not only, in fact, it appears here from your presentation, structural engineers, but also all the other disciplines as well that actually make it into a project. I'd like to thank Hyman, who's the current chairperson of the structural division, for actually doing a joint venture with the IT division. I think it's really good for different divisions to get together and share and disseminate information. So thank you, Hyman, again. And of course, thank you to Debbie for all the organization in the background. It's often the background people that do all the work and don't get any recognition. So thank you very much, Debbie. Just so before we close, just as a heads up, the structural division on the 14th of June, doing a half-day workshop concerning dolomites, and I guess founding structures probably on dolomites. So if you're interested in that, that's the 14th of June, and look out for the invitation from the structural division. And the IT division have also got a webinar coming up on the 23rd of June, and that's going to be entitled The Data Revolution, Digital Twins and Other Smart Technologies. So make a note in your diaries there, the 14th of June workshop on dolomites, and the 23rd of June for digital twins and other smart technologies. And of course, finally, don't forget to check up or follow us on the social platforms, where you can find more information from the various divisions at SAICE, but the structural division and the IT division, so to stay in touch. So thank you very much, all of you, for joining the session tonight, and on behalf of the IT division and the structural division from SAICE, we thank you very much for attending, and we wish you good night.